Given the following position versus time graph describing the motion of some object, answer the following questions assuming that position is given in centimeters and time in seconds. So we've got this cool graph here that's showing us kind of a one-dimensional motion that is happening in time, and it's really graphing position versus time. So note that, I mean, this shape here is two-dimensional in the graph, but we're representing, again, a one-dimensional motion. And in that sense, if you were to try to visualize what this motion would look like in your head, it wouldn't look like this. But you just see an object maybe moving to the right for a certain amount of time, stopping, then more quickly moving to the left to get back to where it started, stopping for a little bit again, then very quickly moving to the right again till it got to a position of 6 centimeters, immediately changing, turning around and going maybe slightly slower until it actually went past the origin to the left into negative position land, you could say, and then again quickly turning around and quite speedily returning back to the origin. That would be like my description in words of what this thing actually means and how to interpret it. So that's something that's good to recognize. Graphs give us a way of describing motion, but you have to sometimes put a little thought into thinking like, well, what motion, like what would that motion actually look like? But now we're going to look at these questions, because the first one here is, what is the average velocity from 0 to 6 seconds? So 6 seconds corresponds to this spot on the horizontal axis right here, and that corresponds to a position where it just kind of stopped right there after moving for a little bit. It came to a rest right there at 4 centimeters. So that looks like a displacement of 4 centimeters over a time of 6 seconds. And in that sense, I think I could just reduce that fraction there and turn this into like a fraction of 2/3, and then maybe I'll rewrite the units kind of separate from that as centimeters per second. So that's a pretty good answer. Maybe if somebody said, well, hey, in science, are we always supposed to write decimals? And I know there are science classes that have that rule. And if you were to take 2/3 and rewrite it as a decimal, it would be like 0.6666 repeating. Maybe I'll consider for right now. I mean, not everyone might agree with me with this. It's okay if you did more by me. I'll just say that. Like if you wanted to say, oh, it's 0.667, it's 0.66667, whatever, however many you want. I think maybe if you did just one, like if you just said, okay, let's round off to the 10th place, 0.7. If that were an exam, I might wonder, and if no work were shown, I'd kind of wonder, like, okay, did they get there correctly? And that's my main concern. And if somebody else just said, you know what, 2/3 is 2/3 centimeters per second, and make sure to include the units. That's a really big rule for this class, is if there are units, you need to have those in your answers. It's super, super important to track units, make sure you convert appropriately, and report them as appropriate. So this, to me, is also, therefore, an adequate answer, even though I know there are some science teachers that do not like fractions. But I am not one of those. I am cool with it. So here's the answer in the slide. You can see both of those are presented there. Let's look at the next question. It says, what is the average velocity from 7 to 9 seconds? So now we're looking at a different time interval. 7 seconds corresponded to where it was resting for like a second there, I think, right? Because 7 is like 2, sort of past the 5 there, right? And then it's starting to move back towards the origin. And it's saying average velocity 7.9, so it looks like it started at 4 centimeters, wound up at 0, because at 9 it's just touching down there, or, well, maybe that's not appropriate description, but there it is. It's coming to rest again at the origin. So thinking, maybe this one I could think about like final minus initial, because it winds up at 0, right? It started, its initial position was 4 centimeters, and it did that with a final time on the clock of 9 seconds, an initial time of 7 seconds. So, of course, that's 2-second duration. I probably could have just written that. But this, I think, turns into minus 4 centimeters for 2 seconds, which maybe I could then restate that simply as minus 2 centimeters per second. And if you were really picky about significant figures, and if somebody said do 2 significant figures for everything, maybe you could have written minus 2.0. But I am, again, not that picky about that. I talk about it, but I'm not that super picky on exams about that, like little things like that in that sense, because we don't really know what the measurement error is here. But the minus is important because we were talking about velocity, so we have to include that minus sign to indicate direction for a one-dimensional motion. All right, let's move on here. What is the average speed from 0 to 3 seconds? So this may be related to the first question we already answered, which was the average velocity from 0 to 6 seconds. This is half the time there. Should it be any different? Well, this object was moving at a pretty constant rate here, as you can tell by the fact that there's pretty much a constant slope here as you go from the initial spot to where it wound up at at 6 seconds. It also might make sense that if we're talking about 3 seconds, it is at 2 centimeters right there. I think 3 seconds corresponds to right that halfway point right there. So this is going to be that same 2 centimeters per 3 seconds. So that's really just 2/3 centimeters per second. The fact that it's asking for speed, that doesn't really change anything from what I just said because it's not negative. So there it is, 2/3 centimeters per second, or 0.67 centimeters per second is okay for that one. Now we have the question of what is the average speed from 7 to 9 seconds. So 7 to 9, again, was that return motion part right here, which before when we asked for, this is basically the same question we already asked a couple questions ago, except then we were asked for average velocity, and we got -2 centimeters per second. So I think for this one, the difference is we're asking for average speed. Everything would look the same as I did here, but I'd have to recognize speed cannot be negative. Speed does not include direction. It always is just a magnitude. So that means it's just going to be 2 centimeters per second. So that's the deal with that. What is the average velocity from 0 to 9 seconds? Oh boy, this got a little bit interesting because we're talking now about a time where kind of different things have happened. It kind of moved one way, stopped for a second, and moved back, right? But here's the thing. There was 0 displacement for that. It started at 0. It wound up at 0. We're being asked for average velocity, so I don't need to overthink all the things that happened on the way. The answer is just going to be 0. There it is, just 0. What is the speed at 15 seconds? So how do we do that? This is kind of an instantaneous question, right? And we're talking, let's see, 15 seconds. That's like right there on the time. It looks like it's probably right at 3 centimeters, judging by the way that crosses there. How do you determine at that instant? Well, the thing you can do is recognize it really wasn't changing speed through this segment of the motion that I'm kind of tracing out right here. So if I look at that and just take some part of it, some time interval, and basically find the slope, that's going to correspond to the speed. I'll have to make it positive, though, because it looks like it's negatively sloped, right? But so like maybe if I look at here, I think that corresponds to time of 13 seconds and a displacement of 6. And then going from 13 to, I think, 17, that's a time of 4 seconds. It went from 6 to 0. So that would be like 6. It looked like that was 6 centimeters over 4 seconds is what I just visually looked at right there. So that returns me to that, that reduces to, I should say, 3/2 centimeters per second. Or if you like, this one you could rewrite as 1.5 centimeters per second. So that's what I'm saying. And note again, I said if this had been velocity, I probably would have to make the top part negative because this was actually a final position of 0 for the part that I looked at right there. But there it is. It says 3/2 centimeters per second. And I said, shh, don't tell the sig fig police, because sometimes people who are really tough on sig figs will say you have to use a decimal. And I just put 3/2 there. But on the slide here, I did put the 1.5 that is equivalent to in centimeters per second.